Looks like we're there. Page 280, exercises 5.4. In problems 1 through 4, write each number in expanded notation. And the number given for problem 2 is 30.2959. So the way I do it is I put the place values up above. Above the 0 is 10 to the 0 power. Above 3 is 10 to the first power. Above the 2 is 10 to the minus 1. Above 9, 10 to the minus 2. See what happens? That's the place value chart. So now, with my place values in mind, I can come down here and write 3 times 10 to the first. See where that comes from? Plus 2 times 10 to the negative 1. You say, wait a minute, you left one out. Yeah, that was 0 times 10 to the 0. But what's 0 times any number? So I just didn't put it there. I mean, if you put it there, it's not going to change anything. But you don't have to write it there since there's a 0. Then it's 2 times 10 to the negative 1. And then plus 9 times 10 to the negative 2. Plus 5 times 10 to the negative 3. Plus 9 times 10 to the negative 4. You follow the technique? You put the place values above the placeholders, the numerals in the number, and then you can use that to write your expanded notation. Any questions? Number 4. So it has 4 and then 30008. So I do the same thing. 10 to the 0, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, 10 to the minus 5. So then I end up with 4 times 10 to the 0, which is just 4 times 1. Plus 3 times 10 to the minus 1, and then 0, 0, 0, so I go plus 8 times 10 to the minus 5. And you see, I determined it was minus 5. How did I know that was minus 5? Because of putting my place values up here for my decimal points. You follow me? If you put those numbers, the first place is 10 to the minus 1 to the right of the decimal point, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, 10 to the minus 5. The next one will be 10 to the minus 6. So that's the way. So what you might want to do is just make a place value chart for decimal numerals, and then just keep it there in front of you so you can look at it when you're trying to work these problems. But I'm not going to work them in my head. I have to write these numbers above the placeholders to know which kind of notation I'm going to use when I expand it. So what about questions about number 4? What about number 6? Number 6 says, write each number in standard decimal notation. Okay, 10 to the second power, what would that be? That would be 400, wouldn't it? Plus 0 times 10 to the first, that would be 0. Plus 5 times 10 to the 0, that would be 5. Remember, 10 to the 0 is a name for 1. Plus 0, then I put a decimal point, times 10 to the minus 1, plus 0, no, plus 6 times 10 to the minus 2. That's, what would that be? 6 hundredths. Plus 0, plus 9 over 1 with, see, this 2 says 1 with 2 zeros. This 4 says 1 with 1, 2, 3, 4. And if you think about decimal places, this is the tenths place, the tenths place. This is the hundredths place. This is the thousandths place. And this is the 10,000ths place. If you're thinking of place values about the way you were taught earlier in life. So, what's the answer to this problem? Let's see. It's 405 point what? 0.0609. Everybody see the process? Any questions? You got it? Let's do number 8. Okay, now when you see that -1, you go, okay, that's a decimal point right there. You follow me? And that 2 goes right there. No, it doesn't. Because in front of that is 10. No, that's right. 2 goes right there. Then what's the next one? -2 would be 5 goes right here. -3 would be 0. And -4 would be 4. So it's 0.2504. And I suppose you could put over here, it's 0 times 10 to the 0 power, which would just be a 0 there. If you wanted to put it there just to make it look prettier. Questions? You really do need a place value chart, don't you? To have it as a reference. So make a place value chart and then put it in your notes so you can keep it handy for test time. Problem number 10. Write each number in scientific notation. Scientific notation. Did all of you read on page 272 what scientific notation is? Scientific notation is a number greater than 1 and less than 10 times 10 to some exponent. So if I'm going to take this number and make it a number greater than 1, I'm going to put the decimal point here, and I have 3.72. That's scientific notation. That's the first part of it. Then, what did I do to get the decimal point from here to here? I moved it one place to the right, which means that's times 10 to the -1. Okay? Number 12. 3,453,000. What would that be in scientific notation? We're still doing, yep, scientific notation. Well, it would be you see, I want a number between 1 and 10. So it'd be 3.453. Then I have to go times 10 to some power. And how did I end up getting a 6? Well, where's the decimal point now? Here. How far did I move it to move it clear over to here? 1, 2, 3, 4, 5. I moved it 6 places to the left, so I put a 6 as the exponent for 10. Follow the rationale? When I move it to the left, it's going to be a positive exponent. When I move it to the right, it's going to be a negative exponent. When I move the decimal point to get my number between 1 and 10. Just write yourself some notes and keep them handy, because the textbook doesn't give you enough practice to get it fixed in your head. But you know what? If you had a whole page of these to work, you probably still wouldn't get it fixed in your head. So you might as well just write the notes down and say, I'll bring the notes with me to test time so I know the procedure to follow when I'm doing this. Number 14. Now they're giving me a number in standard, in scientific, this is scientific notation, and they say write it in a standard notation. Well, so watch what happens. I have 9.01, so I put that down here. Then it says 10 to the 7th. So I just add some zeros. 1, 2, 3, 4, 5. It's okay if you put all 7 of them up there. I mean, if you're just looking for an easy way to work it. Now what happens is I'm going to change to blue here, because now I have to move this decimal point 7 places. 1, 2, 3, 4, 5, 6, 7. So I bring that decimal point right down here, and what's in front of it? A 0, a 0, a 0, a 0, a 0, a 1, a 0, and a 9. Everybody see what happens? And what does that become? 90 million. Let me change it to black. 90 million, 100,000, and there's my decimal point. And how did I get that? This said 7, so I moved the decimal point 7 places to the right. You follow the strategy? And I've got a couple of extra zeros. It doesn't matter. I just put them there to make sure I'd have enough. Number 16, 4.02 times 10 to the negative 7. So I put down 4.02, but which way am I going when it says negative? I'm going this to the left. You follow me? So I have 7 of these, so I move the decimal point from here down to here. I move it 1, 2, 3, 4, 5, 6, 7 places. And the answer is 0.000000402. And to check it, if I have this number, that's going to be 4.02 times 10 to the, how many places do I move it back to get to 4.02? 10 to the negative 7. Remember that? So from this number, that's why it's a negative 7. So I know if I have negative 7, it's going to be a number less than 1. It's going to be a fraction. So when I put it in scientific notation, I'm going to have a negative exponent. You got that? Number 18. Let's do a little multiplication. So I guess I better get my calculator out here, because it could be we're going to need it. We'll see what happens. What's 7.41 times 2.25? Anyone have a calculator? Did you get 16.6725? Yes? Okay. Then, what's 10 to the, what is this? Negative 3 times 10 to the 5th. What do you do when you multiply exponential numbers? Add the exponents. So that gives you 10 to the 2nd. Negative 3 plus 5 is 2. Now the problem is, this is 16. I want 1.66725. So I change this number to this number right here. Then I still have my 10 to the 2nd. So my final answer is 1.6725 times 10 to the 3rd power. Everybody see what's going on? I take 16.6725 and make it 1.66725 times 10 to the first. So I can say, why am I doing it? Because I'm putting it in scientific notation. And if you translate it from scientific notation, this first number would be 0.00741 times 225,000. And if you multiply those two with your calculator, you get 1,667.25. And if you move that over there, then that becomes 1.66725 times 10 to the third power. I mean, if you just want to check your work by looking at it another way. Any questions? Number 20. Another multiplication problem. And this time, I take 4.9 times 3.5, and what do you get? Did you get 17.15? Or did I make a mistake? Did you get 17.15? You don't know. You're not going to tell me. All right, then I'll just do it myself, said the little red hen. 4.9 times 3.5. 17.15. Thank you, little red hen. You are welcome. Then I take 10 to the negative 2 times 10 to the negative 1, and you add those two together and you get negative 3. Everybody follow that? But see, now I have 17.15 times 10 to the negative 3. So I change this to 1.715 times 10 to the first, then times 10 to the negative 3, which results in 1.715, which is what I need for scientific notation, times 10 to the 1 plus negative 3 is negative 2. Everybody follow that? What do you think? Are we having fun yet? No. Doesn't look like on your faces you're having as much fun as you did on Monday. Number 22. That's why I ask you to read the pages, kind of help you get ready for this stuff. Number 22 says 8 times 10 to the second times, nothing's written there, so it means times 3 times 10 to the negative 2 divided by 24 times 10 to the negative 3. What's 8 times 3? 24. And what's that divided by 24? So there's 1, right? So I have 1 times what? Ten to the 2 plus times 10 to the negative 2 is 10 to the 0. Agreed? Then 10 to the 0 divided by 10 to the negative 3. What do I do with the exponents? When I'm doing division, subtract. I go 0 minus negative 3. Remember, I subtract the bottom one from the top one. What's 0 minus negative 3? That's 0 plus what? 3. So the answer is 3. So it becomes 10 to the third. 1 times 10 to the third. You can't do this in your head. You have to work it out on paper. Remember I said on Monday, if I don't see your homework, I'm not going to give you credit for doing these assignments. You have to show your work. Number 24. Sir Arthur Eddington claimed that the total number of electrons in the universe is 136 times 2 to the 256. So that's what Sir Arthur said. But look what else. problem 24 says. It can be shown that 2 to the 256 equals what? Approximately 1.16 times 10 to the 77. Do you follow what I'm doing so far? If this number is times this and equals this, is that the same as taking, let's put this in scientific notation, 1.36 times 10 to the second? Everybody see where this becomes, does everyone see where this becomes this? Or do I need to go over here on the side and work it? You got it? You see where it comes from? So I've got 1.36 times 10 to the second times, and then since this equals this, I can put this in place of this for my multiplication process. It's called substitution. So I'm substituting 1.16 times 10 to the 77th in place of 2 to the 256th power. Now I'm back to multiplying, so let's go back to black again. What's 1.36 times 1.16? 1.5776 times 10 to the second and 10 to the 77th would be what? 10 to the 79th. Add the two together. So what's the answer? 1.5776 times 10 to the 79th. Okay, now what's this number? Let's change this to green. Does that help? No. Let's change this to blue. Yeah, blue's a little better. What's this number all about? I just felt compelled to do this because remember the book talks about doing work to correct number of decimal places. So if this number has 3 digits in it, 3 significant digits, and this one has 3 significant digits, then that means I want 3 significant digits in my answer. So I would take 1.57, and because this is a 7, I would make it 1.58 times 10 to the 79. If I was following the rules for significant digits and rounding for multiplication. And now the answer in the book, I think the answer, see, you have to look at the question. Are they going to ask you to put it in scientific notation? Are they going to ask you to put it to the correct number of decimal places? You have to read each question to see what it is they're asking and then do what they tell you to do. And page 278 is where it explains this stuff that I was doing in blue. If you haven't read it yet, you might want to look at it while we're working through these. Problem 28. How many meters per second is that? Oh, that's 27. 28. The U.S. oil reserves are estimated to be 2.2 times 10 to the 10th. That's this number right here. That is supposedly how much oil we have underground waiting to be pumped out of the ground and used for gasoline to make our cars go. According to problem 29, we use about 7.2 times 10 to the 9th. This is how much we use every year. Isn't that what they said? Annually? per year. At this rate, how long will the oil reserves last? So I take the total oil reserves and I divide it by the amount that's used each year. And guess what this problem says in the book? Back when this book was written quite a few years ago, that it looks like we only have about 3 years of oil reserves left. Now, if that would have really happened, if there was no more oil to be found in the world, and that would have happened, we would all be getting to school today with pedal cars or electric cars that run off of natural gas. But does anyone know what's happened since this problem was written for this book? Has anyone discovered any new oil fields anywhere? Have you read about any of those in the news? There was one recently discovered up in Alaska that apparently is bigger than any oil reserve we've ever found before. Off the coast of South America, they've discovered oil reserves that they had never known about before. So, do you understand? We keep discovering new oil reserves every time we get to the place where somebody thinks we're about to run out. A number of years ago, quite a few years ago, people were so concerned about running out that they were coming up with ideas for how people would get to work. And that was when I lived about 15 miles from here. And I said to my wife, look at this PPV that they're going to start mass producing and selling. And it's called a people-powered vehicle. And it looked like it was, you know those bicycles where the guy's laying down flat, pedaling? You see one of those going down the road? They had taken one of those and put a kind of a shell around it to make it aerodynamic. And then we would just get in one of those when we left and start pedaling down the interstate, coming to school. And it would take me about 35 minutes to get to work, because it was geared to where you could pump it up pretty fast and make some pretty good time on the highway. So I said, if we run out of oil, I'll just have to buy one of those. Well, we haven't run out of oil because we keep finding new reserves. So don't get alarmed. If you don't find more reserves, your generation will figure out how to get to work riding a bicycle, which probably would be healthy for you anyway. Oh, do you see how I got 3.1? 2.2 divided by 7.2 is 0.30, and 10 to the 9th divided by 10, or 10 to the 10th divided by 10 to the 9th is 10 to the 1st. And then when I move this over, no, that's not right. I made a mistake. When I move this over here, what does that do? That's 3.1 times, yeah, that's right, times 10 to the negative 1. I didn't make a mistake. Because 3.1 times 10 to the 1st would be 31. So it's 3.1 times 10 to the negative 1, and then 1, and that adds up to nothing. So it's just 3.1 years they say we have left. That's just wrong. Problem 32. What are we doing on 32? Perform the indicated operation. So we have 18.64. Do you know to always line up the decimal points when you're adding numbers? And then you say, there's nothing above the 3. Well, then put a 0 there. Because isn't 64 over 100? Isn't that what 64 is, 64 hundredths? Isn't that the same as 640 over 1,000? Just add a 0 to each one. You follow the thinking? I think they called it in grade school annexing zeros. They just often didn't tell you why it works. Okay, let's erase that. Now let's add these two together. 3, 8 and 4 is 12, carry the 1. 6 and 1 is 7, 7 and 9 is 16, carry the 1, put down the decimal point. 8 and 1 is 9, and there it is, 19. Oh, no. What did I do wrong? Oh, man. What's 0 minus 3? I can't do that. I have to borrow from the 3, and that means I have 10 of these, and 10 of these minus 3 of these is 7 of these. And then 8 from 3, I can't do that, so I have to borrow, make that a 5, and this becomes 13. 13 minus 8 is 5. Then I have 5 minus 9. I can't do that. I have to borrow again, and I have 15. And 15 minus 9 is 6. Put the decimal point down, and 7 and 1. No wonder I did addition. It's so much easier than subtraction. Let's just do the easy operation. No, let's do the one they're telling us to do.
Dr. Bonai?
Uh-huh.
Could you just use a calculator for that?
Sure. But it's more fun to do it your... No, it isn't, huh? Yes, you could use a calculator for these. Now, look at this one. What's negative 18.64 minus 0.983? Remember, that's on a number line, like starting at 0 and going to the left, 18, and then going to the left some more. You follow the thinking? So what do I have to do to find the answer here? Now I add. And I get 19.623, but it's a negative number. Everybody follow that? Because they're both negative, I have to add them together. This one here that we just worked was one positive and one negative. So I have to subtract and take the sign of the larger number, if you remember your rules. And if you don't, then write them down, because you got to keep them straight. Number 34, multiplication. Well, as much as I would like to do it, running out of time. So let's just take 2.48 times 2.7 equals, and what do you get? 6.696. Is that what you got? And then, now we're doing multiplication again, but this time it's a negative times a negative. So what's the answer going to be? Positive. And since it's the same numbers, it's going to be 6.696. Because a negative times a negative is positive. Well, let's do some division. Negative 1.8 divided by 0.9. Let's just get our calculator. And let's put in 1.8, and remember it's negative. And then divide by 0.09 and equals, and what do you get? What did you get for an answer? Negative 20. Is that what everybody got? You go, that doesn't look right. It looks to me like it ought to be negative 2. Well, change it so you feel good about it and see what happens when you check it in the back of the book. Have you learned that lesson yet, or are you still working on it? 3.6 divided by negative, so the answer is going to be negative. Then I just have to divide 3.6 by 0.012. Say, well, 12 goes into 36 3 times. Yeah, but it doesn't come out that way when you do your calculation, because you go 3.6 divided by 0.012, and you get what? Negative 300. Okay? Number 40. You got to learn this problem early in life, or you get in trouble when you go rent a car. Ann, poor Ann, rented a car at $25 a day. Well, that's not bad. I'll rent a car and take it on my trip. Then I won't have to worry about it breaking down. Plus 15 cents per mile driven. What was her cost for a 2-day trip where she drove 700 miles? So Ann rents a car to drive from here to Oklahoma City to visit some friends, and she gets back, and what's it going to cost her? Well, $25 a day for 2 days, that's $50, right? Yeah, but 15 cents times 700 miles, that's $105. Now you see why when you go rent a car to go someplace, there's a magic word you want to make sure you get: unlimited mileage. You pay by the day, no matter how many miles you drive it. Because when you start, you say 15 cents a mile, that's not much. When you take 15 cents times 700 miles, it comes out to be $105. So then you add those two together, and all of a sudden, instead of paying $50 to rent the car, plus whatever 15 cents a mile would be, she's paying $155. So, yes?
Does that include gas?
What?
Does that include gas in your bill?
No, you pay the gas yourself. And if you don't fill the car up before you take it back, they will fill it up with their own pump. But guess what the price per gallon is for their pump? $5 a gallon. And they add it to your bill. So if you emptied the tank and they had to put in 20 gallons worth of gas, you just paid another $100 for gasoline. Whereas if you'd have filled it up yourself, it would have cost you more like, what, 50? So that's why people usually fill up right before they take the car back. Problem number 42. A worker is paid $4.50 per hour. So this is his pay, $4.50 per hour for 40 hours a week. And it also says he's paid an additional $1.50 per hour for everything over 40. You follow that? So how much is his paycheck for 3 weeks? He worked 43 hours the first week, 42 hours the second week, and 45 hours the third week. Well, what did he get for the first 40 hours? For 40 hours, he got $180, didn't he, every time? Everybody follow that? What's 40 hours times 450? 450 times 40 hours is $180. Then, here he has 3 hours extra. So what's 3 times $1.50? No, I'm sorry. Not $1.50. For those 3 hours, he's making $4.50 plus $1.50. So he's making $6 an hour. So what's $6 times 3? 18. What's $6 times 2? 12. What's $6 times 5? 30. So how much pay did he get? 198 plus 192 plus 210. Everybody follow the process? You better learn how to do this too. You go to work someplace where they pay overtime for over 40 hours and you don't keep track of it. And it could be that they might just shortchange you because you don't know what's going on. The problem is, that happened to me one time. I didn't watch what was going on. I wasn't paying attention, and I thought, hey, they take care of stuff. They'll figure it out. And my supervisor just put down that I didn't get paid for overtime. I was just doing it because I liked where I worked. And at the end of the year, the company auditor who audits them for tax purposes said we could get in trouble for having Tom work for nothing. So the auditor made him write me a check for all my overtime. How cool was that? But it taught me a lesson. Be sure and keep tabs on stuff, because there are unscrupulous people out there who will take advantage of you. Number 44. Yeah, we all check books out of the library, and the overdue charge is 10 cents for the first day and 5 cents each additional day. So this guy paid a fine of 75 cents. Well, 10 cents for the first day, so that means he's left with 65 cents. And if it's 5 cents each day, then I divide 65 by 5 and I get 13 days. Plus the first day would make a total of 14 days that the book was overdue. Do you follow the thinking there? Do you see how to go from words to just some mathematical information that I can use to operate on? Any questions about that one? Number 46. Round 45.49 meters to the nearest meter. To the nearest meter. Now, is this number closer to 45 meters or 46 meters? That's the question. Which is this number closer to? 46.00 or 45.00? So the answer is 45 meters. You remember your rules for rounding? If this would have said 45.59, what would it be when I rounded it? It'd be 46. Everybody see why? Because this 59 is more than halfway to the next number. Does that make sense to everybody? Good. Questions? 48. The sides of a triangle, a triangular lot, are measured. So they measured these. These are measurements. This long, and this long. And then what do they want to know? The perimeter. You know what perimeter is? It's all three measures added together. Perimeter is the distance around the outside. If you don't know that, then write that down. So when you see the word perimeter, it means the distance around the outside. So we add those three numbers together, and what do we get? But look what it says for problem 48. To the correct number of decimal places. Now, how many decimal places do I want in my answer? Okay, how many decimal places in this number? 1. How many decimal places in this number? 2. Everybody follow that? How many decimal places in this number? 0. Everybody follow what I'm doing? Now, if you look at page 277, guess what it'll tell you? That when you round the answer to the correct number of decimal places, you can only have as many places in your answer as you have in the number with the least number of decimal places, which means I have to go with 0. So this number has to be rounded to either 12.06 or 12.07. Maybe I'll write them the other way around. 12.06 or 12.07. I mean 1,207 or 1,206. Now, which one is 0.35 closer to? 207 or 206? 206, so I round it to 1,206. Everybody follow that? Number 50. A business reported annual sales of 8.5 million. That's the sales. And their expenses were 6.52 million. What's the profit? Does everyone understand that profit would be sales minus expenses? So I just subtract 6.52 from 8.5, and what do I get? 1.98. But look what it says for problem 50. To the correct number of decimal places. How many decimal places in this number? 2. I'm sorry. 1. How many decimal places in this number? 2. Yeah, that was, you say, why did you say that? Because in the book it said 8.5. So how many in my answer? 1. So to the nearest, now do I leave this as 1.9 or do I make it 2.0? Because this is an 8, what do I do? Everybody see where I make it 2.0? Do I leave it 9 or do I go up one more? And one more would be 2.0. And it's 2.0. Number 52. On October 17th, 1965, the New York Times contained a total of 946 pages. 946 pages. The thickness of a page is 0.0040. But do they print on both sides of the page? So when it says there's 946 pages of reading material, like for example, from page 280 to 282, there's 1, 2, 3 pages of reading material, or like on page 281 and 282, there's 2 pages of reading material, but it's only 1 page of thickness. You follow me? So I have to divide 946 by 2 to get the actual number of pages of paper. And then what happens when I multiply that? I get 1.892. But to the correct number, what did it say to do for 52? To the correct number of decimal places. So what do we have here? We have how many decimal places here? 1. 1 significant digit. You go what? Oh, we're multiplying. Look at page 278. We have 1 significant digit in the measurement. This is how thick a page is. That's the measurement. So we want 1 decimal place in our answer. So what's it going to be? 1.9 inches. Number 54. Lionel Harrison drove the 1,900 miles from Oxford, England to Moscow in a Morris Minor. He went 1,900 miles with 62 gallons. So I divide 1,900 by 62 and I get 30.6456. And what does that come out to be? What did 54 want me to do? Round the answer to the nearest tenth. The nearest tenth would be right there. Do I leave it 30.6 or do I make it, so the nearest tenth means do I leave it 30.6 or do I make it 30.7? And you look at the 4 and what do you conclude? You leave it 30.6. Number 56. The highest average yardage gain for a football season belongs to Beatty Feathers. He gained 1,004 yards in 101 carries. What was his average number of yards per carry? Average number of yards per carry. So I divide the total by the number of carries, and I get 9.940594. And what do they want me to do with it? Give the answer to the nearest tenth of a yard. See, sometimes they say to the correct number of significant digits, and other times they say to the nearest tenth. So tenth would be right here. So what's the answer? I circle the 4 and say, do I leave it 9 or add 1 to it? I leave it 9. Okay? Number 58. What's number 58 say? The longest and heaviest freight train on record was 21,120 feet long, and it had 500 cars. This is the total. And these are the number of cars. How long? What do they want to know? Where'd it go? How long was each car? How long is each car? So I divide this and I get 42.24. And what do they want me to do? Do they say? To the nearest foot. So I go to the nearest foot. Do I leave it 42? Or do I make it, add 1 and make it 43? I look at this number and say what? Leave it 42. Everybody follow that? Good. Stop when you get to problem number 57. And it looks like we've done enough of this for one day. If you have any questions or need some help with the problem, stick around and I'll help you. Turn this off.